Hello, good evening. Hello, am I audible? Vaishnavi, am I audible?
Yes, sir.
Yeah, okay. And my PPT is visible?
Yes, it is.
Okay, slides are changing or not? Please confirm. Slides are changing?
They're changing, sir.
Okay, okay. Okay, so good evening all. I welcome you to live session number 2 for week 2 for the course Non-Conventional Energy Resources. The course instructor is Professor Pratap Haridos from IIT Madras and I am his TA Amit Kumar Sharma. So every week we are conducting this live session to solve some sample problems and to revise the concept from the previous week. So last week we have covered the week 1 classes and we have also done some sample questions and I think that helped you a lot in your week 1 assignment. So now in this session I will cover the week 2 course material and I will also do some sample problems on week 2 content. So based on that, you will be able to solve the week 2 assignments. Okay, so let's start with the basic revision for week 2 content. So this slide explains the world energy use. So I have also explained in my last session that what is the energy use in our world. So basically we are dependent on the basically on oil. You can state 33% of oil, like 33% of energy use is coming from oil and 30% is coming from coal and 24% from natural gas, 7% from hydro, 4% from nuclear and 2% other. So this pie chart is explaining that humanity depends on fossil fuel for 87% of our energy needs. So this amount is very high. You can see that 87% of our energy needs are dependent on fossil fuels. And we all know that fossil fuels are limited, okay, and they are associated with the high environmental pollution. So as we know that the world population is increasing day by day. So as the population is increasing, and also as we today we see that our like energy use is increasing drastically because we are using various appliances, we are using various type of systems and energy systems also, and we are like exploiting the energy. So the demand of energy is increasing exponentially in recent years as compared to the previous decades. Okay, so this increasing demand can double or can triple or can multiply the amount of CO2 in the environment because the main energy is coming from fossil fuel, like 33% from oil, 30% from coal and natural gas. So basically these are contributing factor in our energy needs, the world energy needs. Okay, and we know that increasing amount of CO2 leads to global warming and climate change. And today we are also facing various issues due to this global warming and climate change. And we all know that the UN is working on it, and all developed nations are working on it. Okay, so we have to work towards the climate mitigation, and for that we have to go for energy resources that are in renewable nature. Okay, so we have to like decrease our dependency on the fossil fuels. Okay, so today we are focusing on various non-conventional energy resources. So this course. So in this course, we are learning non-conventional energy resources and also about what are the resources that we are using. So again, this slide is taken from the Wikipedia from recent data. Okay. So this is like specifying the what are the current current energy use, like in petroleum product 28%, coal 27%, Natural gas 23%, renewable 19%, nuclear 3%. Now this renewable, you can see that it's around 19%. So this renewable is also having multiple subparts in it. Basically, what is the meaning of renewable? So renewable means the energy which can be renewed, okay, which can be renewed in a particular time frame in which we are using it. Somebody will say that fossil fuel is also renewable because after millions of years, like the the fossil fuel, we will we all get the fossil fuel again, but it take millions of years, so that will not for our use. So renewable means the energy which can be renewed in our particular time frame. Okay, so renewable is that, like solar. Okay, we are using it again daily, on daily basis we are getting the solar energy. You can say the biomass. Okay, like you can see the tree leaves. Okay, so we can generate the biogas from tree leaves, and again the tree leaves will be grown after some days. You can say also agriculture residue, like in agriculture residue is every season we get agriculture residue of the cutting of the farm produce. So in that way, that is the renewable. So this renewable energy also, this pie chart is explaining the contribution of renewable energy. So the maximum contribution is from biomass, 53%. So 53% contribution is from biomass, 23% from hydropower, 15% from bioheat, then 2% from wind, ethanol, biopower 2%, solar heating 1%, biodiesel, geothermal, solar PV, and ocean power. So these are the major contribution from the renewable energy. So the main thing is that in renewable energy, we are mostly dependent on the biomass. Okay. So biomass we are using 53%. Then hydropower. So hydropower include the energy of water using dams. Okay. Some water turbines. From that we use this hydropower. Bioheat, like heat generation from the some like some I think it's also included by heat from biomass only. You can see the solar PV is 0% only. Solar PV is the solar photovoltaic cells. Okay, so 0% means it's not completely zero, but you can say that the current contribution of the solar PV in the world energy use is almost zero. Maybe it will be 0.05 or 0.08. So it's as compared to the hydro, biomass, and other sources, it's around 0%. But it is increasing drastically. Every nation is working on the solar photovoltaic. Okay, you have seen in recent news that India is also working on solar farms to produce the electricity from solar energy. Okay, and we are also like planning to install some hydrogen electrolyzer to generate the hydrogen from solar energy, because you know the electrolyzer requires uh, around 49 kWh for 1 kg of hydrogen production. So if we use the current electricity, then that hydrogen will be not be green, it will be gray, because the pollution is associated with the hydrogen production. So for green hydrogen, we require the energy that is produced from some renewable source. So the solar PV is having huge potential today and in future. Okay, so geothermal is only 1%, ocean power is again 0%. So these are the contribution of renewable energy in the world energy use. So solar PV is very important in it because the contribution of this is increasing, and it is very good actually. Uh, you can also say that the cost of solar PV is recently come down to a huge margin. Earlier, like for 1 unit solar electricity, the cost was around 9 to 10 rupees per unit in India. But now today I think it's 2 to 3 rupees only. And today we can see that in every household. So government is also providing subsidies. Government is also providing subsidies for the solar installation on houses and for solar installation in the farms. Okay. Various farmers are using solar power water pump for watering their agriculture farm. So government is also providing number of subsidies to increasing the solar PV contribution in the renewable energy sector in India. Now these are very important terms like non-conventional, renewable energy, and clean energy. So non-conventional energy, renewable energy, and versus clean energy. So conventional, it's mean that we are using from a decade of times or uh, from some past times, okay? And non-conventional, that is not that is something new or that is not used from past. So that is from the meaning of non-conventional energy. Renewable, as I have already told, that energy that can be renewed or replenished in a particular time frame. This is important. Clean energy. So it is not important that every renewable energy is clean energy. Okay. Clean energy is energy that will not affect the surrounding environment. Okay. Because whenever you are using an energy that is associated with some pollution or some other factors that will affect their surroundings. Okay. So energy which after using does not affect the surrounding. Suppose the surrounding is having some particular composition of gases. So after using that particular energy, the composition of immediate surrounding is not affected, not changed. That means that that energy is a clean energy. So basically, the energy which is not creating the pollution at all, considered as clean energy. But it's also uh, like you can say the electrical, like electric vehicles are we are considering electric vehicles as clean energy. Yeah, it is because at immediate surrounding, any electrical vehicle at immediate surrounding that is not creating the pollution because there is no combustion. We are using the batteries only, and battery is powering the engine. So in batteries there are electrochemical reactions, and there is no pollution in the electrical vehicles. But there is also a catch. Uh, whenever you do the cradle to grave analysis, means how that electricity is generated for that particular electrical vehicle, then the scenario can be changed. At the immediate surrounding for electrical vehicle, you can say that this is clean vehicle, this energy is clean energy, but the electricity that you have used to charging your vehicle, so how did you get that electricity? That is also a question. Okay, because if you are charging your electrical vehicle, electrical battery at your home, okay, so at your home you are receiving the energy from government supply, and government supply is getting the energy from some power plant, and that power plant is mostly based on the thermal power plant or mostly based on coal power plant. So basically you are getting the energy from a coal power plant. Okay, that energy you use to charging your vehicle. So for your immediate surrounding, your vehicle is, you can say, non-polluting. But if you analyze the complete cradle to grave, that how you get that electricity, then it's not renewable. It's not clean because earlier when your vehicle was using petrol or diesel, it was polluting immediately. But now the pollution has been shifted to the that power plant because the pollution is generating in the power plant only. That power plant is supplying the electricity to your home, and from your home you are charging your vehicle. So it depends on the on your perspective how you are taking the things. Okay, so for a complete analysis, for complete uh, like cradle to grave analysis is very important in this. So we have to see the things on a broader perspective. So on this Venn diagram, is showing that like three intersection points are there. This intersection point, this point, this point, and this point. So there are three energy: non-conventional, clean, renewable. So it's not important that every renewable energy is clean. Okay, because suppose biomass is, we can say, renewable energy, but if you are burning the biomass, okay, like in the old cook stove, you can see that most of people are burning the biomass to for heating purpose and for cooking purpose. So the biomass is, you can say, renewable, because after one season you will again get the wood, you will again get the leaves and other biomasses. But you are burning directly, so you are polluting the environment. So that is not clean. It's renewable but still not clean. So it is not essential that every renewable energy is clean energy. Again, every non-conventional energy is not renewable or clean, and every clean energy is not need to be renewable or non-conventional. So there are some intersection points. So we have to clearly identify the energy. So it comes in under which category? Mostly our focus is on this area. It should be renewable, it should be clean, and also on this area it should be non-conventional, clean, and renewable. So this particular area is very important. Okay, so this area is our important area. So these are some sources by which we are getting the energies, like from biomass. Like from biomass, we are burning of wood or other organic matter. So burning of wood is also creating energy in the form of heat. Okay, you will directly get the heat, but that is not clean. So using biomass, we can burn the wood or other organic matter and we can get the heat, and that heat can be used to generate the steam, to generate like to cook food, and for other many purposes. Like wind energy. So in wind energy, basically there is a huge rotor, and we put the rotor at a particular height. At that height, that rotor will capture the velocity of the wind, and the blade designs are in such a way that the wind will rotate those blades, and a turbine is attached with those blades. So the turbine will, in the shaft will rotate in the from the wind force, and so the electricity will be generated. So in India, Jaisalmer is very potential area for the wind energy. Jaisalmer, Rajasthan is having numerous capacity of wind farms. Okay, due to the high wind condition in that particular area. In Gujarat also we are having some wind energies farms. Okay, so whenever the government is planning to install, or whenever any like energy company is planning to install a particular farm in a particular area, then we have to do some feasibility study of that area. After that only we can install these things. So wind energy, we require the speed of wind, and maybe we have to monitor the average speed of a particular year, or maybe for 5 to 10 years, because whenever you install a wind turbine in a particular area, it's not for short term, it will be for a long term. Okay, so you have to analyze the data for past 5 to 10 years of a particular area, and you have to understand the what is the average wind velocity, what is the potential of wind energy in particular area, and on that data you can install wind energy. Hydropower. So hydropower is like simply we are generating the energy from water. Okay, so we collect water in dams at a particular height, and we release the water in a particular manner, and that water will rotate the blades of a turbine, and we will get mechanical power, and from that mechanical power we can generate the electrical power. Okay, so basically we are converting the mechanical power into electrical power from wind energy, from hydropower. Okay, so for cities and states, large hydropower plant and small hydro plant are option like 100 megawatt to 10 gigawatt, and for small hydro up to 30 megawatt. For isolated homes and small communities, micro hydro 5 kilowatt to 100 kilowatt, and for pico hydro by below 5 kilowatt are recommended. Okay, but again, these are having some drawbacks also, because whenever you install a like large hydro dam, then you have to displace the immediate population to safe area, because if you are having a large hydro plant or large dam in a populated area, then it will be very risky for them. So these are very disruptive actually, and the cost is also very huge, and it also require huge time also. Okay, so these projects are quite lengthy, but we are having but these are pure renewable power, because it is not associated with any carbon emission, because you are directly converting the mechanical power to electrical power, and you are using the water force only. Now come to the solar energy. So solar energy is having two parts. Everyone, are you able to see the pointer in PPT? Hello? Anyone, are you able to see the pointer in the slides?
No, sir.
No, sir.
Not able to see the pointer?
No.
Okay, let me. Are you able to see now? Like I'm selecting the solar energy part. Are you able to see the right sign on it?
No, no.
Once. Now the marking is there or not? Are you able to see any marking?
No, sir.
Yet no. On which slide you are currently? You are able to see which slide? Biomass and hydropower slide. Is it okay?
Sir, biomass, hydropower, wind energy, and solar energy.
Okay. I am underlining hydropower. Are you able to see?
No, sir.
Okay. Now are you able to see? Any underlining on the text?
No, sir.
Okay, okay. Next time I will check. Okay. So in solar energy, there are two options actually, solar PV and solar thermal heating. So basically, solar thermal heating is like very old technique in which we use solar energy to heat the water or heat particular matter. Okay, and we can use it later. So you can see these are the tubes in solar thermal heating. So water like the cold water flow from these tubes, and the solar energy is concentrating on these tubes, and that will give the energy to the cold water, and at the other end the water will become hot and will be stored in the particular tank. So basically we are directly using the solar thermal power to heat the water. So it's quite popular and very cheap also. So it can be installed on like some hotels and in our houses also, so we can get the hot water in winter season. We can also install some electrical heating element in this, because sometimes the suppose in winter season the sun rays are not strong to heat to provide the solar thermal radiation to the water to heat it like a required temperature. So we can, for a particular time period, we can start the electrical heating to heat the water, and we can use it. So it's a very good solution. In our IIT hostels we are also using this type of solar water heating for our hot water requirements. The next one is solar energy from photovoltaic cells. It's also very popular actually. So in this, these are the some cells that can directly convert the solar energy to the electrical energy. But the efficiency is very low. It's around 20-25% only. So all over the world, scientists are working to increase the efficiency of these cells. But this technology is very good actually. So in India, we are installing huge solar farm to produce the solar electrical energy in a large amount. Are you able to see now the any underline on the text? Okay, I will check. The next is geothermal energy. So in geothermal, like Earth is made of when we dig the Earth, so there are multiple layers. Okay, so from these layers, at some part of the Earth crust, we are getting steam. Okay, so we are getting high temperature steam. So we can use that, or and we can use directly that steam, and also when we dig dig the ground, so after a certain depth, the temperature difference is there. So the temperature is very high at the after a certain depth, so we can supply the cold water from top, and at the bottom, that heat will the temperature will increase the temperature of water and generate the steam, and that steam can be utilized to run a turbine, and from the turbine we can convert the mechanical energy to the from generator we can convert the mechanical energy to the electrical energy. So this is geothermal energy, like we are using the energy from beneath the earth. Second is wave and tidal wave. So oscillating water columns compress air and like oscillating water columns compresses air and drive a turbine. It can be noisy. Tidal barrage strategically locating specialized dams. So at some areas there are predefined tides are coming. So that when there's a high tide and low tide, so based on that, we can arrange a system so that will generate the energy. Ocean thermal energy conversion. So at sea, at sea level, there is a warm water at the surface of the sea around 25 degree, but at at 1000 meter deep, the temperature is cold water around 5 degree. So you can see that there's 20 degree temperature difference from 10 meter to 1000 meter. So we can use this temperature difference to drive a heat engine and to get the energy. Now, electrochemical devices. So this is very important and hot topic from today's scenario, because we are moving towards the clean energy and for efficient energy. So these electrochemical devices include fuel cells. Okay. So fuel cells in fuel cells we know that there is no combustion. In electrochemical device there is no combustion. So we are converting the chemical energy to directly electrical energy. Okay. So we can get the maximum potential of that particular chemical. Like in IC engines, we are burning the fuel. So first we are converting the chemical energy of fuel to the mechanical energy, and from that mechanical energy we are converting it to electrical energy. Okay. So there is a long process, and every process has its own efficiency. So the final efficiency will be very less. It's around only 30 to 40% max. But fuel cell can go up to 65 to 70%. Okay. So in anode, electrode and cathode, okay, so we supply the fuel. So some electrochemical reactions are there. So based on that, we can get the electricity. Now let come to some sample questions. Okay. So first is GDP of various nation is very closely related to the. So we are talking about the GDP of various nation. So GDP is connected to which? The first option is energy consumption, then incident solar energy, presence of wind farms and forest area in the nation. So we can eliminate the option like forest area in the nation cannot represent the GDP. Okay, presence of wind farms also it's not relevant because it's presence of wind farms will like show the amount of wind energy available in that particular country. Okay, incident solar energy it's also it also deliver that what is the potential of solar energy generation in that particular area. Now energy consumption, yeah, it can be a factor connected to GDP. Okay, because energy consumption, if the energy consumption is more, means that particular country, okay, the people in that country are using more energy. Maybe they are using more energy, means they are having availability of more resources. So based on that, it can be connected to the GDP of that particular area. So the right answer is energy consumption. Second question is, what are the cleaner source of energies? So as we have seen that cleaner source means that will not generate the pollution, that will not affect the surrounding, immediate surrounding environment. Okay, like solar energy, yeah. So solar energy, it can be generated from the direct solar heat. So there is no combustion, there is no like any machine or anything involved that will generate or make pollution in immediate surrounding. Like in solar thermal heating, we have seen that solar energy can directly heat the water, and in solar PV, solar energy can directly convert the solar energy to the electrical energy. So solar energy is the right option. Then maybe the multiple options are correct. So we have to check other options also. So wind. So again, wind energy is also clean because uh, because you know that because the wind energy will directly convert the wind velocity to the electricity. Okay, using the wind turbines. Okay, so wind turbine with the velocity of the wind turbine will rotate, and the rotation will generate the mechanical power, and from the generator that mechanical power will be converted to the electrical power. Okay, so there is no scope of any pollution associated with the wind energy, so it is also a source of clean energy. Geothermal, so again we are using the heat uh, beneath the earth to run a turbine. Okay, to run a steam turbine. So it's also not linked with any pollution or like any source of emission. So it's also a clean source of energy. Ocean thermal energy. Yeah, again, we are driving a heat engine based on the temperature difference from the surface of the sea and from 1,000 meter, you can say some very deep to the ocean. So solar, wind, geothermal, and ocean thermal energy, both these four options all are correct. So next question is renewable energy sources are. So as I earlier said, renewable means energy source that can be replenished in a particular time frame. Okay, so biomass, yeah, biomass can be renewable because suppose you are having a particular forest, you are having a 10 acre of forest. So you will decide that uh, first I will grow, first I will use the 5 acre of forest for my energy use. Okay, and I will again plant some trees in that particular 5 acre, and when those trees are growing, I will use the next 5 acre. So in a cycle, you're again using the 5 acre, and again you are planting the tree. So you are getting, you are renewing your particular energy source. Okay, like for agriculture residue. Solar PV is also renewable because we are using the solar energy, and that is we are getting it daily. Okay, so it is renewable. Fossil fuels. So fossil fuel require millions of year time. So in our particular time frame, we cannot renew the fossil fuel, so it's not a renewable energy source. Diesel, again, it's a part of fossil fuel, and it is not a renewable energy source. So the correct option will be biomass and solar PV. Yeah. So biomass and solar PV are considered as the renewable energy sources. Now match the following. Non-conventional energy sources. There are three options: A, B, C, and there are some options. So anyone want to try? Yeah, please write your answer in the comment box, because these are interactive session. So it will be good if you participate. So try to solve this. These are all linked to the revision material I have covered, and the class material that have professors have already covered. So please try to solve. Let's take 2 minutes. So what can be the correct option for A, non-conventional energy? Type in the chat box. Okay, for B, renewable energy, anyone? And for C, clean energy.
Sir, first option.
Yeah, for non-conventional energy, which one is correct?
Majority of us are using.
Okay. So A, you are saying A to 5. So yeah, non-conventional energy, majority of us are using. Yeah, it's correct. And for B, renewable energy.
First option, nature or human can renew in a certain time frame.
Yeah, maybe the multiple options are correct. So you can see other option also. Yeah, it's one is correct. Nature or human can renew the energy in a particular time frame. Yeah, it's correct. Please look into other option also. Maybe one or two can be correct. Meanwhile, for C, clean energy, you are saying the correct option is 4. 4, na? Benign with the environment. Okay, yeah, it's also correct. But for option B, available in inexhaustible form, because
Yes.
yeah, because renewable means it can be renewed, like solar energy. Okay, it cannot be exhausted. Every day we are getting the solar energy, so it is available in inexhaustible form. Okay, so the correct options are yeah, it's actually the A is non-conventional energy. So majority of us are using conventional energy. Okay, so sorry for confusion. It's non-conventional energy. So majority of us are not using it. So third is correct. If it was conventional energy, then the option will be fifth, because majority of us are using. So it's non-conventional energy. So majority of us are not using non-conventional, because we have seen in one slide that 87% of our energy needs are fulfilled from the fossil fuels. So we are using the mostly conventional energy sources. So non-conventional energy sources we are not, majority of us are not using. For B, renewable energy, yeah, option 1. Nature or human can renew the energy in a time frame, and option 2 is also correct, available in inexhaustible form. For clean energy, C, benign with the environment. So it's good for the environment. Okay, in balance with the environment. So it's not polluting the environment. Is my video visible? Are you able to see me?
Yes, sir.
Yes?
Yes, sir.
Yeah, okay. The fifth question is advantage of micro dams over large dams. So, anyone want to share some thoughts? What can be the advantage of micro dams over the large dams? As I have earlier said in one PPT that for large dams, it's quite difficult for the people who are surrounding, and also the cost is very high. Time is very high. Required time is also very high. So, what are the advantages of micro dams?
Sir, low transmission cost and low transmission loss. C.
C. Okay. Any
And
other
four,
options?
sir, infrastructure can be quickly built.
Yeah, that is no, that can be correct. Yeah. What about the first option? Less disruptive. Is it correct or not? Because if the dam is micro dam, then you can build it in a small area. Okay. So you don't have to worry about like migrating the more people to the from that area. Okay. So it will affect only a particular small area only as compared to the larger dams. So options are less disruptive, low transmission cost, and low transmission loss. Infrastructure can be quickly built. Because if the dam is very large, then it requires more time. So try this one. Match the following. There are four options: A, B, C, and D. Wind energy, geothermal, solar, and ocean thermal energy. And there are some other. You have to link 1, 2, 3, 4. So match the following. For wind energy, which options can be correct? Yeah, is wind energy utilize the concept of temperature difference? Yes or no? Do wind energy utilize the concept of temperature difference? Yeah, anyone? Okay. What about geothermal energy? It geothermal energy utilize the concept of temperature difference? Okay. What about solar energy?
Sir, solar energy is affected by the seasons.
Okay. Now you have to actually go through all the options. You can see that solar energy, like there is a fourth option for photons. Photons are the energy
Photons are
packets.
the energy packets. Yes,
Yeah, yeah, right, right. So solar
that's
energy can be linked to that, and you were saying that affected by the seasons. So affected by season will be which one? Wind energy, because the speed of the wind can be vary. Okay, because in every season we are having different temperature, and when you see the speed of the wind, it's depend on the temperature difference actually. Okay, temperature difference of the land, temperature difference of the complete environment. If you are in the near sea, then temperature of the sea and the land. Okay, so due to the temperature differences, the speed of the wind affected, and it also affect on various other regions also. But seasons affect the speed of the wind, and the speed of the wind will directly affect the wind energy. Because if the speed of the wind is high, it means that your wind turbine will get more rotation speed, and the more rotation speed means more mechanical power. More mechanical power means more electrical power. Okay, so option A will be wind energy will be affected by the season. So A will match with the 2. Now geothermal energy. So geothermal energy, as I already told you that we can tap off the very high temperature of the beneath earth and convert the water into steam directly. and can run the steam turbine. So geothermal energy tapped in the form of steam. Okay. Now solar energy, see, photons are the energy packets. Ocean thermal energy. So as I already told you, the temperature difference between the surface of the water and the temperature which is at 1000 meter deep is having huge temperature difference around 20 degree. So that temperature difference can be utilized to run a heat engine. Okay, that can be converted to the electrical energy. Okay, so the correct option will be A2, B3, C4 and D1. Now come to the next slide. So energy tapped from renewable sources can be stored using. Yeah, so which option can be correct? Anyone? You are having options of batteries, fuel cell, ice engine, nuclear plants.
Sir, batteries and fuel cells.
Okay. Anyone? Anyone else? Okay, let's see. So nuclear plants. So from nuclear plants, from the name itself, we can see that nuclear plants means we are using some nuclear reactions and generating electricity. So basically, nuclear plants are plants where we are generating the energy. Okay, we are not storing it. So nuclear plants cannot be the option. Now come to the IC engines. IC engine means internal combustion engines. So basically, IC engines, like in every vehicle, there is IC engine. Okay. In locomotives, we are using diesel engines. So basically, the engines which are internal combustion engines mean basically we are using a fuel to combust, to burn, and to convert the chemical energy of the fuel into mechanical power. Okay, that is IC engine. And with the help of generator, we can convert the mechanical power to the electrical power. So IC engine again is not storing anything. Now fuel cell and batteries. Yeah. Actually, fuel cell and batteries both are electrochemical devices, but there is a difference. Okay. Fuel cells, there is a huge difference in batteries and fuel cells. Like batteries can store the energy, but fuel cell cannot. Okay. So fuel cell will generate the electricity as long as there is input supply of the fuel. Okay. So whenever so you are supplying some fuel into the fuel cell, you are supplying the hydrogen to fuel cell. So as long as the hydrogen is there, your fuel cell will generate the electricity using electrochemical reactions. Whenever you stop the supply of hydrogen, your fuel cell will be ineffective because there is no fuel, there will be no electrochemical reactions, and you will not get the electricity. But on the other side, batteries. So batteries can store the energy. Okay. So you make batteries, you already store energy in it in like some chemical form, like you insert some material which can be used whenever you apply the load. Okay, so batteries also have capacity, but it cannot require the continuous flow of the fuel. Okay, it can store the energy, but fuel cell require the continuous flow. So energy tapped from renewable can be stored using batteries only, like in the case of solar PV. Okay, so in daytime we are sun rays are very high. Okay, so in daytime the solar energy is sufficient to generate the electricity directly from the solar panels, and we are getting our load directly from the solar panels. But at the night time, the solar radiations are not high enough to generate the electricity or generate the sufficient load. So there is no solar energy at the night time because sun is not there. So at night time, but we require electricity. So in daytime, the excess electricity will be stored in the batteries, and nighttime we will use the batteries, and daytime those batteries will be charged from that solar energy. So batteries only can store the energy. But again, there is a very important question, like a very important point about the batteries. Okay, so today we are looking toward batteries, but we have to also see the cradle to grave analysis. Okay, so we are using the batteries in like electrical vehicles for storing the energy, but what about disposal of batteries? Because after certain period of time, these batteries will be no use, will be no use of. Okay, so we need to replace these, and when there is no use, so these are very hazardous material. So the management of batteries, okay, after their life, it's a very complicated and very tough process, and it will also create, it's very hazardous to the environment also. So we should like government should also look into these factors also, because the grave analysis is also very important. Okay, so in future we have to come with a solution with the technologies that can handle the dead batteries. Okay, so batteries after their life is over, we have to look in that part also. So the accepted answer is batteries. So an electrochemical device consists of an anode, cathode, and an electrolyte. So an electrolyte can be in the form of a solution during its typical functioning when attached to an external circuit with metal wires, electrons and ions flow through. Select the options. So basically it's talking about the fuel cell. So what are the component in the fuel cells, and what are the basic mechanism? So there are electrolyte, electrodes, external circuit. So ions flow through the electrolyte and from electrodes, and the electrons flow through the external circuit. So the correct options will be external circuit and electrolyte, metal wire and solution. Okay, any doubt? Okay. Now again come to some other revisions, like energy consumption by sector. So we have discussed about some energy needs. Okay, now let come to the energy consumption by sector. So basically, these three sectors you can see, these are like average data. Okay, these are not like you can say that specific data for every country. Okay, these are average data. Okay, for the world based on the energy consumption by sectors. Okay, so 45% of energy is used from the industries and services, 35% from transportation, and 20% from residential. So the main thing that is highlighted here is that normally we look into only transportation sector, like we think that only transportation sector is generating the pollution. But from this data, you can easily see that there is one more area which is using the more energy. So if that sector is using more energy, it means that is polluting the environment more. That is industries. But the transportation, we are directly affected. Like we can easily see the effect of vehicle pollution from transportation. Okay, in Delhi itself, there is huge pollution in some months. Okay, AQI index is very high. So the reason is that transportation. Okay, and some burning also. So transportation, everyone can see the effect of transportation on the environment. But industries are located outside the cities, in outskirts areas. So we cannot see the direct effect. Okay, so but it's a point of concern that industries is using more energy than transportation. So when we are talking about like we have to use electrical vehicles, hydrogen vehicles to reduce the pollution, but we should also work, the government should also work towards the modernization of industries, because the industries process are using various conventional energy sources. Okay, and the reason is that whenever industry is established, So that industry, like today's industries, maybe that was established before 10 years or maybe 15 to 20 years. Okay. So they are having some equipments, and the equipment life is for around 30 years, maybe 35 years, because they are investing a huge amount of money. And that is not only for 1 or 2 years. So they have planned for like 30 or 40 years in future. So that machine or that particular process cannot be replaced directly from fossil to renewable. They are upgrading, yeah, right, they are upgrading, but it will take time, and the cost is also associated very high. So we need to look into this also. Okay. So a collective effort has to be done in this area to mitigate the pollution in industries and services. In transportation, government is working all over the world. Electrical vehicle are like getting a huge pace. Okay. In residential sector also, uh, 20% energy is consuming in the residential sector. So the mostly is from natural gas for heating in the cold regions. Okay. And electricity. So in industrial sector, the major energy using area are oil refining, metallurgical processes, glass manufacturers. So these are the major areas of industries which are using high amount of energy. Refining of oil, because whenever we drill the wells, oil wells, we are getting the crude oil. So from that crude oil, we have to separate different products using refining. Okay. And refining is a like a group of various processes, various different process in which that crude oil has to pass to generate different products. Like we are getting petrol, we are getting diesel, we are getting lubricants. Okay. We are getting kerosenes, we are getting some gases also. So that is the part of refining. So oil refining is huge energy intensive process, because for refining we have to we need particular temperature, we need particular pressure. For that pressure we need some pumps, we need some compressor. For temperature we need to heat that we need heat, we need heating. Okay. So we need to burn some natural gas. Okay. So in like this, uh, process heating, refining, crude oil, and boiler heating, these are three main sectors in which industries use energy. Okay. For process heating, raising temperature of components during manufacturing, refining, like separation of products, boiler heating to generate steams. So primary, they use natural gas and oil, and secondary, they use electricity. So the reason is that primary, they use natural gas and oil, and secondary electricity, because we know that electricity is not directly available. Okay. So whenever we want to generate the electricity, we need some prior process. Okay. Either we are getting electricity from you can say the power plants, we are getting from generators. Okay. But again we are converting the chemical energy. Okay. From fossils, or we are converting the solar energy, wind energy, and generating the electricity. So the direct electricity is not available, it comes through a process, and that process is having some cost, that is also having some efficiency. Okay. So the industry will not want to use electricity directly, but some equipments require electricity, so they are using it. But as much of as possible, they will use the natural gas and oil, so that efficiency will not decrease. Okay. So they can directly use that the maximum efficiency available, or maximum overall efficiency. Because if they use electricity, and from that electricity they generate the steam, then it will be not cost effective and not efficient. If they use the natural gas to burn and to generate the steam, then it will be beneficial for them. Because for electricity generation, we are using the natural gas to generate the steam, and from steam we are using generator, and from generator we are getting the electricity, and from the electricity we are again heating the natural gas, like again heating, generating the steam. It's not feasible. It's not a good process. So primary we use natural gas and oil, and secondary electricity. So again, these two pie charts are again explaining the like what are the sectors and what are the points where we are using the energy. So electricity, the lower one pie chart is showing electricity 61%, natural gas 32%, centralized district heating 5%. It's not available in India. Actually, the European Union and other countries where cold weather is the almost present, so they are having central district heating. So they are having like PNG pipelines installed in their home, like water connection, okay, electricity connection. So they are having gas connection also. So they can tap off the natural gas and use the space heating to heating the complete home because temperature is very low, like around -10 degree, -5 degree. Okay, so they need to heat the complete house. So in those areas, they are using centralized district heat and the fuel oil 2%. So come to the upper one pie chart. You can see that how the particular heat is divided. Okay, so mostly you can see that 25% is for space heating. So the space heating will require 25% of energy. So it will be for colder regions. And cooling, you can see 9% for cooling. Okay. So cooling, so in the hot, in the areas where the climate is hot, so in that we need cooling. So we are using air conditioning. Okay. And today the air conditions are like quite affordable. So this percentage is maybe increasing in like in some upcoming years. Okay. Ventilation 10%, refrigeration again 10%, lighting 10%, computer office equipment 8% only, cooking 7%, water heating 7%. So these are some areas in which we are using the energy commercially. Okay. So the major areas are space heating, cooling, lighting, ventilation. Okay. Now the sources of fuel for transportation sector. So what are the major sources for fuel for transportation sector? Because transportation sector is very important. Because in our earlier slide we have seen that like 35% of energy consumption is by transportation sector. So we need to find the way by which we can introduce a renewable energy in transportation sector. Government is trying to find a way to reduce the use of fossil fuel in transportation sector. So in transportation sector, that 35% is how further divided. So that 35% is further divided in this can be seen using this pie chart. So petrol 38% in petrol vehicle, diesel 38% diesel vehicles, jet fuel 14% in aeroplanes. Okay, residual fuel 7%, etc. Natural gas 2%, electricity 1%. So measure is petrol and diesel. So the potential of electrical vehicle is very huge. You can see that if and you can say also hydrogen vehicles also. Okay, but there is some problems with the hydrogen vehicles like storage, because you know the power density of hydrogen is very less. So storing the hydrogen is also, we need to require very high pressure. So for a vehicle that require pressure around 700 bar, it is quite high. So hydrogen vehicle is quite risky for smaller vehicles, but for larger vehicles, for larger transportation vehicles, it can possible. And research is going on towards this sector. Okay. So electrical vehicle can be used to replace the diesel and petrol. And we can also see some other. So if we replace the petrol and diesel, so we can we can address 76% of that 35%. Okay, because 38% diesel, 38% petrol. So we can decrease the dependency of the fossil fuels if we move towards the electrical vehicle and hydrogen vehicles. So this transportation sector can be powered with the renewable energy. Like in my last class, I have told you about CBG, compressed biogas. Today we are having CNG vehicles. So CNG vehicles basically compressed natural gas vehicles. So those vehicles are not using diesel or petrol gas; they are using natural gas. So in this pie chart, you can see 2% is use of natural gas. But again, natural gas is fossil fuels. Okay. So today we are using compressed biogas. Okay. So we are generating the biogas from agriculture residue, mostly from agriculture residue, from sugar industries residues. Okay. From various organic matter. Any organic matter can generate the biogas, and that biogas is having around CS4 percentage from 50 to 60%, and remaining around 40% CO2 and very minute percentage of other gases. So that biogas can be upgraded to the compressed biogas. Okay, so that upgraded biogas, or you can say upgraded biomethane, will have the CH4 content about more than 90%. So that will be equivalent to natural gas, because natural gas is having CH4 content is around 90 to 93%. Okay. So that upgraded biomethane or upgraded biogas can replace the natural gas. So that is quite beneficial, and government is also working very hard toward this sector. And under Satat scheme, government is planning to install 5,000 CBG plants, and almost around 40 CBG plants are already established. So they are generating tons of compressed biogas per day, and that can be used for the transportation vehicles. For that compressed biogas can be directly filled in the CNG vehicle. So in this way, we can reduce this natural gas use. That is 2%, so it can be further reduced. Okay, it can be further reduced by CBG, and the diesel petrol is also decreased. If we increase the number of vehicles that will run on the CBG, so these two will also decrease, and the content of renewable energy in the transportation sector will increase. So we have to work towards CBG, we have to work towards the electrical vehicle, we have to work towards the hydrogen vehicle. So these three areas can be worked to reduce the dependency on the fossil fuel in transportation sector. Now this is global transportation consumption. So this data is showing the global transportation consumption. So there's a unit MBD. MBD is millions of barrels a day. So energy source for transportation like 88 MBD is showing. The total amount is considered 88 MBD, and oil 96%, biofuels 3%, and electricity 1%. So again, the 96% of global transportation is dependent on the oil only. So that is very huge. So we have to replace it. This number is very high actually. So we have to increase the renewable energy content in the transportation sector, so we can reduce the consumption of fossil fuel. That will be good for our environment. And there is one line mentioned in this slide, that traffic jam wasted energy, wasted time. So all over the world, we know the traffic jam is very big problem, because in traffic jams, the air fuel ratio, the new vehicles are having some features uh, uh, that can reduce the that can control the consumption of the petrol or diesel during the whenever your vehicle is idle at the signals, and whenever you are idle in the traffic jam. But the old vehicles, like 3 to 4 years back vehicles, they are not efficient for signals and traffic jams. So so they are polluting more actually. Okay, because we know that IC engine, whenever a vehicle run on their economy speed, okay, around like for bikes around 40, on for a four-wheeler it can be around 80, 60 to 80. So at that range, the air fuel ratio is optimized, so that air fuel ratio will emit a very low pollution as compared to the rich mixture as compared to the lean mixture. Okay, so traffic exams are wasted of energy and wasted of time. So we need some technology also that can mitigate this issue also. So it can also save an a good amount of energy. So this pie chart is again describing a basic use of energy in a home. Okay, like in our home we are having a number of appliances. So we are using different appliances for and they are using energy. So this data is showing average use. Okay, like 41% for space heating. So again this data like considered for average. So it's taking the areas of winter region, like cold climates or winter region area, because they require space heating. So the most of energy required in go into the space heating. Then the electronics, lighting, and other appliances 30%. So electronics, like various devices, laptops, desktops, sound systems, mixer, washing machines, any other electronic devices, appliances. So they will use around 30% of energy. Water heating, in cold climate, we need to heat the water. Okay, so again 18%. Air conditioning, 6% for hotter regions, 6%. Refrigeration, 5%. So these are the basic data use of energy in a home. So major contribution towards the space heating and electronics, lighting, and other appliances. So this is a example of a typical California home. So again here you can see that 22% is lighting, 19% refrigerators and freezers, 15% TV, computer and office equipments, 10% air conditioning and spa, pool and spa, 6%, dishwasher and cooking, 5%, laundry, 5%, space heating, 4%, water heating, 3%, miscellaneous appliances, 11%. So in this way, uh, using this example, we can estimate energy of our home also. Okay, we can like make a chart. We know the wattage capacity of every equipment, because every equipment having some particular wattage capacity. We know that how much time we use this particular equipment. So based on the wattage capacity, based on the time of usage, we can find out our consumption of particular that particular product, and we can estimate the consumption of per month. Okay. And this pie chart is showing the commercial sector energy use overall. So in commercial sector, this pie chart is showing the energy use, like space heating again 36%, lighting 20%, cooling 8%, ventilation, water heating, refrigeration, cooking, computers, office equipment, other. So these are the energy use for commercial facilities like office buildings, malls, hospitals. Okay, any commercial space. So these are the patterns. Okay, so based on these patterns, we can find out the areas and find out the source of the energy in that area. Okay, and we can work to replace the fossil source using renewable source. Like for space heating, like 36% is going for space heating, and mostly in the colder region for space heating they are using natural gas. So at this point, we can replace the natural gas from CBG, compressed biogas. Okay, so we can target a particular sector and we can reduce the burden of fossil fuels. We can reduce the consumption of fossil fuels like lighting. Like today, like 20% is using on lighting in commercial building. Like buildings are using various type of new fancy LEDs, various of fancy lights, but they are not required actually. If the design is such that the natural light, because office hours, you know that it's 9 to 5 only. Okay, most of office are 9 to 5. So 9 to 5, there is sunlight. So the design of office should be like that. The proper sunlight should be present. Okay, so that can be done. So that will decrease the electrical demand for lighting. Okay, so in this way, like ventilation, 7% is for ventilation. So again, the design can be so that it can use natural ventilation. So what for water heating, we can use solar thermal water heating. Okay, for cooking again, we can use uh, the pipeline biogas. So based on these sectors, we can find out the areas where we can replace the consumption of fossil fuels and we can use non-conventional energy resources. Okay, so these are the areas of a particular sector. These are for commercial and these are for a particular home. Now again come to some questions like almost 90% of fuel in the cars is used to. Yeah, very good question. Anyone? Almost 90% of the fuel in the cars is used to option A, transport the driver alone, B, transport the car itself, C, transport the air in the car, transport the fuel in the car.
Transport the car itself.
Yeah. And can you explain also?
Sir, fuel is used to do combustion and then is used to transport the car itself.
Okay.
Means car transport the driver,
So correct option is transport driver or transport the car?
transport the car itself.
Okay. And why the option A is not correct? Transport the driver alone, because whenever we are like driving a car, actually we are moving from one place to another place. So basically we are using that particular vehicle for a commute to one place to other. So
Sir,
can option
the
A not be correct?
driver is sitting in the car.
Okay. Okay. Right. Yeah, if you right, driver is sitting in the car, you are transporting the car. Yeah. But why the 90% of fuel? Why because the 100% fuel is going in the engine, na? So where is the rest 10% is going? Let's read the question carefully. Almost 90% of fuel in the car. So we are not talking about 100% of fuel. We are talking about 90% of fuel. So what is the reason that only 90% we are considering? And the answer, you are saying that transport the car itself. So you can think some other reason also. Try to think. Okay. So basically the engine is in a car is generating some energy. Okay. And that energy, that mechanical energy is used to transport the vehicle from one location to another. In that particular vehicle, a driver can be there, passengers can be there. Okay. Suppose there are 4 people in the car. So everyone is having weight around 60 to 70 kg. Okay. So total weight of 4 people will be around 250 kg, let's suppose. Okay. But the car itself is having average weight of 1000 to 1200 kg. Okay. Or maybe 13, or some car are up to 1500 kg. So whenever you compare that, you are burning the fuel. So you are moving that car's weight plus the passenger's weight. And you can see that if there is suppose only one passenger in the car, and that person is having around suppose 60 kg, and the weight of the vehicle is around 1000 kg. So you can see the difference. So the most of the energy is only for pulling the car from one point to another point. Only a fraction of energy is for that 60 kg person. Okay, so this is a very good point that we are spending the so much of fuel, we are spending the so much of energy to transport that car's weight from one point to another, because the weight of the driver is very less as compared to the car's weight. That's why 90% of fuel in the cars is used to transport the car itself. Only 10% of the fuel will be used for the driver passengers. Okay, so basically the 10% of fuel's power is for driver and passenger. So the main point is that the 90% of fuel is using for car's weight. So you can see there is a huge there's a huge gap. Okay, so if suppose you develop a technology that can reduce the weight of the car, okay, the strength of the car will same and the other parameters will remain same, and you reduce the weight, then what will happen? Suppose now your car weighs only 500 kg, then what will happen? Anyone? If you reduce the weight of the car, then what will happen?
Sir, if the weight of the car is reduced, then the mileage of car is increased.
Yeah, because you need less energy because the weight is reduced, so overall weight will be reduced. So you require less energy to move that particular weight from one location to another location. Okay, so maybe the 90% of fuel will be not required. We will require only 60% of fuel. Okay, so mileage will be increased. So in this way, if if the research happens and the weight of the car is reduced, okay, or you apply some aerodynamics and do some like mechanical engineering and design a car that is having a quite low weight and quite efficient. Okay, so in this way we can reduce the use of fossil fuels. Okay, so try to think in these perspectives. By these perspectives only we can improve the non-conventional energy resources. Okay, so the correct answer is transport the car itself. Now next question is fuel to space ratio defines how space a fuel is burnt. So as I have already mentioned that every IC engine is having a particular ratio of fuel and
Air and cleanly.
yeah, right.
Option C.
Yeah, option C is correct because air fuel ratio is very important because for combustion of any fuel we require oxygen and oxygen is present in air. So how much oxygen is there in air? In our previous class we have seen the composition of atmosphere. So what is the percentage of oxygen in the atmosphere? Anyone? What is the approx percentage of oxygen in the air? It's around 21%. So we are having 21% of oxygen in the air. So we require air and fuel ratio. So if the air fuel ratio is optimized or is well stoichiometric, so then the combustion of the fuel will be very proper, and like if the combustion is proper means there will be less smoke mean less pollution. Okay, so it indicate if the air fuel ratio is stoichiometric or idle, you can say that very optimized, then the proper combustion is there, mean less pollution is there, so it means that how cleanly a fuel is burnt. Okay, so fuel to air ratio defines how cleanly a fuel is burnt. So correct answers are air and wind. Now there are some other true and false. Uh, First one is biomass constitutes a significant fraction of renewable energy sources. True or false?
True.
What is the reason?
Sir, biomass is also one type of renewable energy source.
Yeah. Why it is renewable?
Sir, we can renew the energy from biomass. Means again.
We can grow the biomass again.
Yes.
Yeah. So the correct answer for one is true. Second one is per capita energy use is approximately the same internationally. True or false? Per capita energy use. What is the per capita energy? Means energy used by the per person in a particular country. Okay. So suppose there is India, China, and Russia, America. So the population of every country is different. Okay. So the overall consumption of those countries are available. We are having the population, so we can divide the total energy consumption of that particular country and divide the number of and divide by the population, so we can get the per capita energy uses. So is it will be same for approximately internationally? Because as we know that
Sir, false.
yeah, yeah, because America is using energy at a high rate. Okay, because their lifestyle is quite different as compared to the India, as compared to the China. So their lifestyle is like more energy intensive. So they will use more energy as compared to the other. So the per capita energy use is different for every country. So it depends. The industrial sector uses significant amount of energy for process heating. True or false? Process heating means the process for a particular, you can say, if we are doing the oil refining, then that oil refining is composed of various process, and every process requires some parameters. Maybe the parameters require some particular temperature. For the temperature, we require heat. Okay, in this sense, the industrial sector use significant amount of energy for process heating. So it's true. Now the biomass implies burning of wood or organic matter.
True.
Yeah. So biomass implies burning of wood or organic matter. Yeah, biomass can be burned. Yeah. Increase in GDP appeared linked to increase in energy uses.
True, sir.
Yeah, because if the GDP is increasing, it means the people are having more resources. They can afford the resources. So GDP is linked with the energy use. So these are the answer: true, false, true, true, true. Are you able to see the answers?
Yes, sir.
Yeah. So now what is the conclusion actually? The conclusion is a considerable nuisance in the energy supply and use scenario. And second one is non-conventional energy sources making only limited intervention across sector at this time. So from first point, uh, we can relate this point to these slides actually. These slides we can see. So these slides are indicating how much of energy we are using in different like different points in the commercial buildings, in our houses, in also in transportation we have seen. Okay, so these are the areas where we are exploiting the energy. Okay, exploiting the fossil fuels energy. Okay, we are not using non-conventional resources. So we have to look into it. We have to work towards it. Like space heating, na, I told you like 41% energy is using in space heating. It can be reduced. Okay, you can see the lighting part in this commercial sector. So lighting part is using 20% of energy. So when an architect can design a buildings in such a way that direct sunlight will be available or sunlight can be used for the lighting purpose, so it can be reduced. So we are exploiting the energy actually. So this need to be addressed. So the conclusion from this week's lecture is that we should know that what areas what areas in a home, what areas in a commercial space, what areas in transportation sector, what areas in industries are using the energy, and what is the reason. Okay, and where we can replace that energy. We need to find those. Okay, so we need to considerable nuisance in energy supply. We have seen that and use scenario, there's a huge nuisance. Okay, non-conventional energy sources making only limited intervention across sector at this time. We have also seen the what is the current use of energy all over the world. So we have seen that 87% of energy is using from fossil fuels only. So a small fraction, around 1 or 2% is only from non-conventional energy source. So it's required huge intervention on the world level to increase the amount of non-conventional energy sources. Okay. Now let's come to the so now anyone want to explain their thoughts about clean energy? Anyone, what do you think about clean energy? I think 2 weeks already completed. So I want to know what you are learning from this course and what are your thoughts about this non-conventional clean energy. So it will give me an idea that how you are thinking, and maybe I will explain in more uh, like in a good way that it will deliver you better actually. So anyone want to share their opinions about this non-conventional energy, this clean energy, renewable energy? Anyone? Anyone? Okay. So let's discuss. Let again, like briefly, we can discuss the biomass. So anyone want to know that what are different way by which we can generate the energy from biomass? The burning of a wood is very simple way, and we are burning of wood from centuries actually. So it's a very old way. From decades we are burning the wood and generating the heat. But what are the other ways which can be use biomass for energy purpose? Anyone? Have you heard about the
Survey
yeah
production biogas by anaerobic fermentation.
that is the one process where you can generate the biogas from anaerobic biomass. Yeah, very nice, very nice. You can generate the biogas. You can upgrade the biogas to biomethane. Yeah. Any other? That is a one process. Biomass, you are generating the biogas. That is a one process, and there are different other process also. Have you heard about the syngas? Synthetic gas. Anyone heard about syngas? Okay. So syngas is basically a combination of carbon monoxide plus hydrogen. So it's a very popular actually syngas. So syngas can be used for generating the heat. Syngas can be used in boilers to generate the heat. So biomass can be used to generate the syngas, carbon monoxide plus hydrogen. So there are different process available, and one of like important is gasification, pyrolysis. So these processes are very important. You can learn on different articles online. You can learn about the gasification. You can learn about pyrolysis. So using these process, biomass can be converted to the syngas, and that syngas can be used in engines also. That syngas can be used in boilers for burning. That syngas have multiple use. That syngas can be like you can mixed with the natural gas. Okay, because that is having hydrogen in it. So hydrogen is having high calorific value. So the mixture of syngas and the mixture like there are dual fuel engine also. Okay, like in diesel engines, we are having diesel inserted. Okay, so with the air, okay, for because we know that air fuel mixture is very important. So we can do some modification in the engine, and with the supply of air, we can mix this syngas with the air. Okay, so some quantity of syngas will go with the air in the engine. It will generate more power. So for a particular like fixed power, the amount of requirement of diesel will be reduced. So it's called pilot fuel saving. So basically, you can save the amount of diesel required for particular power by inserting the syngas. So again, this biomass. So we are getting the syngas from biomass only. So using biomass, uh, not only we can burn it, we can also generate syngas from it. This syngas can be mixed with the other fuels. Okay. Biomass can also be used for generating biodiesel. So today we are replacing the diesel. Okay. So biodiesel is like blended fuel is there. You can say flexi fuels. So government of India is like encouraging the flexi fuel. Ethanol blending is there. You heard about it, I think. So 20% ethanol is blended in the petrol. So that is again generated from organic matter only. From agriculture residues, we can generate the biodiesels. Okay, so that biodiesel can be mixed with the conventional diesel. Okay, so there are research is going on, and there are various approved blending ratios approved for various type of biodiesels that can be mixed with the diesel to generate the power. So in this way, biomass can be used. Okay, uh, we can also generate the hydrogen from biomass. Like gasification, you are getting the carbon monoxide plus hydrogen, and further you can purify the syngas to generate the pure hydrogen. Okay, so this CO plus H2 will be reacted with water in water shift gas reactor. Okay, so this CO will react with water at some high temperature around 300 degree to 400 degree. This further will convert into hydrogen and carbon dioxide. So you will get high amount of hydrogen with CO2, and after that you can purify the mixture of hydrogen and CO2 using some separation technique. So there are various separation technique are available. Some of are pressure swing adsorption. Some are, you can say, membrane separation technique. So there are various techniques available by which you can remove the CO2 and you can get the pure hydrogen. So biomass is having huge potential. As from some data I have gone through, the India is only using around 5% of its biomass capacity, biomass potential. Okay, we are only using 5% of biomass potential. So biomass is having huge potential. In every sector, biomass can play a vital role. Okay, so um, uh, so from biogas we can also generate the hydrogen. So basically, it can be a it can be green hydrogen actually, because biomass we can know is renewable, and we are getting the hydrogen. Currently, the world's around more than 85% of hydrogen is generated from fossil fuels, in which around 45% from the steam methane reforming, which use natural gas, and remaining is from gasification, which use coal. Okay, so this can be this can be replaced from the biomass. So we can develop some greener way, some clean way to generate the hydrogen, because today we are moving, we know that we are moving towards the hydrogen economy, because hydrogen is a fuel, H2. It's not having any carbon. Okay, so the beauty of this fuel is that it's not having carbon, but there is also a limit. It's not available directly. You can see hydrogen, we are not getting the hydrogen in its raw form. Basically, hydrogen is an energy carrier. You can see any hydrocarbon, there is hydrogen in it. Okay, any like methane CH4, there is one carbon for hydrogen. Any higher hydrocarbon you can see, there will be carbon and hydrogen. So basically, hydrogen is not an energy source, it an energy carrier. It carry the energy. Okay, we cannot directly get the hydrogen available in the universe. It's available in the form of water also, H2O. So H2O basically having two moles of like two moles of hydrogen and oxygen. Okay, so either you can split the H2O to generate the hydrogen oxygen. So again, in splitting, you are not getting any carbon. So it's very clean process. So that's why all over the world research is focusing towards the hydrogen economy, because only this is the way by which we can handle the situation of current scenario. Because as we know, the average temperature of Earth is increasing at a very high rate. So if we want to maintain the temperature, if we want to reduce the pollution, we want to reduce the global warming, we want to handle the climate change, because the population is increasing, energy demand is increasing. So we need some clean ways. So hydrogen is the best way available. So that's why all over the world, electrolyzer technology is focusing green hydrogen. All over the world, we are working on the technology. So biomass can play a very vital role in that. And wind energy and solar energy also can play a vital role. Because when I'm telling about like electrolyzer, like we can split the water. We are having plenty of water available on Earth. Okay, so you can split the water, and it's very simple process. You need you need electrolyzer. But the thing is that to break the water, to break the H2O, you need high amount of energy. Around 49 kilowatt hour, means 49 unit of energy is required for production of 1 kg of hydrogen. Okay, so that is very high. So if you are using that energy from the current electrical grid, that is that electrical grid energy getting from some coal or coal power plant, so that is not a green process, because when you do the cradle to grave analysis, you will know that you have generated the hydrogen that is clean, right? Your hydrogen is clean, but the energy you use to generate this hydrogen is coming from the power plant, and that power plant is coal based. Okay, so see the point. You have to look cradle to grave. So in that point, that solar energy, wind energy, hydropower can play a vital role, because energy generated from these processes are not associated with carbon emission. Okay, if you are installed an electrolyzer near the wind farm and you are using the electricity from that wind farm to run the electrolyzer, then you can say your hydrogen is green hydrogen, because that 49 kilowatt hour, that 49 unit energy will come from the wind power only. So there is no carbon emission with it. So you can say it's green hydrogen and you can move with it. And similar for hydropower and similar for solar energy. Because in solar energy also we are converting the direct solar radiation into the electricity. Okay, using the photovoltaic cells. So we can convert the solar radiation to electricity, and we can use that electricity to run the electrolyzer. So in this way, we can move toward the hydrogen economy. Okay, but the main concern regarding hydrogen is safety. Safety is a very important concern for hydrogen, because the storing of the hydrogen is very difficult, because the density of hydrogen at normal condition is around 0.089 kg per meter cube. So it's very less. You can compare it, 0.089 kg per meter cube. It's very less. So you require almost 700 to 800 bar pressure so that you can store the hydrogen in sufficient amount that will last for your requirement. Okay, so that high pressure requires very high compressors. Okay, that compressor again requires some energy, and handling of those high pressure vessels is a complex process and huge process. And okay, and the transportation is also quite difficult, because you cannot detect a minute leakage of hydrogen. It's also very flammable actually. The HHP of hydrogen is around 141 megajoule per kg. So the HHP is the highest in the fuels. Okay, in any known fuels we are having the highest HHP of hydrogen. Like for diesel petrol, it's around 50 megajoule per kg, and it's around 141 megajoule per kg for hydrogen, almost thrice. So the energy content is very high, but this transportation, these are very high issue with the hydrogen. So these are the hurdles which we have to address actually. So we have to work towards these hurdles, and we have to move towards the hydrogen economy. That's why today we are focusing on various methods to green hydrogen. Recently, government of India had launched national hydrogen mission also. Okay, so in that mission they are spending a lot of money for green hydrogen production. So in near future you will see that number of projects will come in this field, and you will see that they will using non-conventional energy only. So you will see the big electrolyzer will set up near solar farms, will set up near wind farms. At that point, you can relate this course. Okay, you can relate this course. And I want to also I want to also tell you some important point about like color coding of hydrogen. Okay, you can see that green hydrogen means green, and there is gray hydrogen, there is blue hydrogen. So there is a different color names for hydrogen. So basically, these codings are associated with the emission generated from hydrogen production. Okay, if you are saying the gray hydrogen means the process is generating the carbon and you are not capturing that carbon. You are emitting that carbon into the environment. So it is called gray hydrogen. Green means there is no carbon emission. Blue means you are emitting the carbon, but you are capturing that carbon. Okay. There is CCUS technique, carbon capture and utilization. So your production plant of hydrogen also having CCU, carbon capture and utilization technique. Okay, so you are emitting the carbon, but you are capturing it and you're utilizing it at somewhere else. So that's why it's called blue hydrogen. So you have to see the coding also. There are different other name also. You can search on the internet. It's a quite interesting topic. Actually, this biomass and hydrogen are actually very easy actually. And the but in today world, biomass is having huge potential. The reason is that because wind energy, as we have seen that it's also have its limitation. Depend on the seasons. It depend on the area. Solar energy again depend on the radiation. It cannot generate in night. Okay. Hydropower again have some limitation, but biomass is widely available all over the world. So if we are having efficient technology, efficient ways to to produce the energy from biomass, that will be a great uh, achievement in this energy sector. Because when we because today we are focusing the huge transportation cost with the hydrogen. So this biomass we can make decentralized solution actually. So this decentralized energy production is very important because like in India, various rural areas are not are connected with the grid, but they are not getting the proper electricity also. So this biomass can be solution for those areas. So the decentralized solution can be done with the biomass. So any thoughts, anyone? Do you want to share something about this energy, biomass, wind, solar, hydropower, anything? It will be good if you share your thoughts. Okay. Then we can also talk about this electrochemical devices. Yeah, it's very interesting actually. Fuel cells are very interesting. Actually, fuel cells are also different types actually, low temperature and high temperature fuel cells. So you have heard about the PEM fuel cell, I think, polymer electron polymer membrane fuel cell actually. So PEM fuel cell operate on low temperature around 70 degree to 90 degrees centigrade. So these are having only anode, electrolyte, cathode. So you supply the fuel. So there are some electrochemical reactions are happening inside the fuel cell, and you are getting the electricity. Okay, but the limitation of low temperature fuel cells are that they require only pure hydrogen. They require 99.99% pure hydrogen. If there are contaminants available in the hydrogen, then that contaminants can damage the electrodes of the fuel cell. Okay, anode side. Actually, the anodes are having some coating of catalyst, so that catalyst helping the fuel to react electrochemically. So if the contaminants are present in the fuel, so those contaminants can damage the catalyst, can deactivate the catalyst. Okay, so the electrochemical reaction will not happen properly. So the purity of hydrogen is very important. So when we talk about the hydrogen vehicle in transportation sector, so in those vehicles, we are planning to use that PEM fuel cell. So this fuel cell, you supply the hydrogen directly and it will generate the electricity as long as the supply of hydrogen is there. And it's low temperature, so the temperature is will be not issue. And the electrolyte is also in solid form. So the handling of electrolyte is also not an issue. So it's quite famous fuel cell. It's commercially available in the market. But again, when we are talking about the transportation sector, some sample vehicles are there. Some companies have researched in this fuel cell and they are having some vehicles running on it. But again, it's quite challenging to store the hydrogen in the vehicle. It's quite challenging. Okay. Uh, but the high temperature fuel cells are also there. Okay, so they can handle the contaminants also. The best high temperature fuel cell is solid oxide fuel cell, SOFC. So that SOFC is quite impressive fuel cell. That cannot be for transport sector, but that SOFC can be used for industrial application. Like in one of the slides, we have seen that 45% of energy is using in the industries. Okay, so they are using various process heat also. We have discussed that. So for those industries, if you want to reduce their dependency on the fossil fuels, then the best electrochemical device will be solid oxide fuel cell. The reason is that SOFC are high temperature fuel cells. They work around 700 degree to 800 degree centigrade. And the beauty of SOFC is that they can handle some contaminants also. Okay. And they don't require pure hydrogen actually. We can supply natural gas also. We can supply higher hydrocarbon also. And due to the high temperature operation, that hydrocarbon can internally reformed in the fuel cell itself, or we can put a small reformer before the fuel cell. The efficiency of the substance is quite high. The exhaust heat can be used using the heat exchanger for the process heat application in the industries. So SOFC are the best device available today that can be used in industries to replace the requirement of process heat, the requirement of electrical heat, electrical energy. So it's quite impressive. But again, the limitation is the cost of SOFC are very high because the material of electrodes are rare earth metals. So the cost is very high. As of now, research is going on to reduce the cost. Maybe in near future, we will see that SOFC will be used for stationary power application. Various companies are working towards it. But initially, when it go for mass production, then the cost will come down. Okay. So in today's class, we have covered the week 2. Okay, week 2, 3 lectures, and we have also discussed some sample problems. I think these will help you in your week 2 assignments, and the PPT and the recording of the session will be available to you. You will receive an email from the course team. So they will share the PPT link and they will share the video link with you. And again, uh, next Monday we will have a week 3 lesson. So we will discuss the course content of week 3 next Monday. Time will remain same 6 to 8. Link will also remain same. Okay, so I think uh, you have learned a lot in this lesson, and I think you will join next lesson also. Okay then. Okay, everyone. Thank you very much for attending this class. Anyone want to say anything? Okay. Thank you very much.